I've held a lot of metal in my time, felt the cold geometry of actions that have seen real dirt, real weather, real consequence. And I'll tell you something that most people who've never stood in a collector's vault will never understand a rifle tells you its history through its engineering. Every decision a designer made, under pressure, under budget, under doctrine, is frozen into the steel. You just have to know how to read it. This list isn't about which rifle looks impressive in a case. It's about which ones change the conversation entirely. 9 platforms. 9 moments where someone said, the current answer isn't good enough, and then proved it in the most unforgiving evaluation environment that exists actual combat. Let's go.
Elite Pistol.
9. Gepard GM6 Lynx, Hungary, 2000s. The company is Accuracy International. The problem they're solving sounds almost absurd when you first hear it. Take an anti-material rifle chambered in 50 BMG and make it fold. Not at the stock, at the action. I've had the opportunity to examine a GM6 up close, and the first thing that hits you is the cognitive dissonance of it. Your brain expects something massive and immovable. A Barrett-class platform that you set up, dial in, and operate from a fixed position. Instead, you're holding 38.6 inches of bullpup semi-automatic that has physically collapsed itself in half. At 26.5 pounds unloaded with a 5-round magazine, the dimensions alone challenge everything you thought you knew about what 50 BMG packaging looked like. But the engineering story is inside the receiver. Accuracy's designers built a long-stroke recoil system in which the entire barrel assembly travels rearward approximately 12 inches before that energy reaches the shooter's shoulder. 12 inches. That's not a muzzle brake doing cosmetic work. That's a mechanical argument that 50 BMG recoil is a times problem. And if you give it enough distance to bleed off before it arrives, a trained operator can stay stable and reacquire for follow-up shots faster than conventional anti-material designs allow. The Hungarian Defense Forces adopted it. Select NATO-aligned special operations units evaluated it seriously. What the GM6 demonstrated, in the language that procurement officers actually care about, was this: anti-material capability at 50 BMG no longer required a fixed, dismounted firing position to be tactically viable. That single engineering argument times compactness without sacrifice times quietly influenced how every subsequent compact anti-material system was specified and judged. 8. FN SCAR 20S. Here's a gap that existed in Western infantry doctrine right up until the mid-2000s, and if you weren't paying attention to the asymmetric engagements of that era, you might have missed why it mattered so much. 400 to 600 meters. Threats were appearing at this range regularly, predictably, and the standard rifleman couldn't reach them. But the threat didn't justify pulling a full dedicated sniper team off its assignment. So what do? You either accept the gap or you build something to fill it. FN's answer was the SCAR 20S, chambered in 7.6 2x51 millimeters NATO, 20-inch match-grade barrel, overall length of 44.5 inches, unloaded weight of 11.3 pounds. Verified consistent accuracy out to 800 meters. What separates this from the designated marksman rifles that came before it, the modified M14S, the accurized AKs, the adapted battle rifles pressed into precision rolls, is that the SCAR 20S was Time's purpose-built. From the ground up, no compromises inherited from a previous platform's design priorities. The free-floating barrel, the adjustable stock engineered for repeatable accuracy under field conditions rather than just on a range. These aren't afterthoughts. They're the founding decisions. SOCOM and allied units documented its performance in rolls where a bolt action was too slow and a standard rifle couldn't reach. The SCAR 20S didn't just fill the gap. It formalized the doctrine that the designated marksman roll times required times, a purpose-built tool, not an adapted one. And that realization reshaped NATO procurement thinking in ways that are still visible today. 7. Sacco TRG 4-2. Finland, the 1990s. A procurement requirement that cuts straight to the coldest truth in military sniper doctrine. The Finnish Defense Forces needed a platform that would function not just survive, function times at temperatures below -40 degrees Celsius. Because in that operating environment, mechanical failure isn't a maintenance inconvenience, it's a death sentence. Seiko's engineers in Rihimeki built the TRG-42 around the 338 Lapua Magnum cartridge, which itself was developed in the 1980s specifically to bridge the ballistic gap between 7.62 NATO and 50 BMG. The TRG-42 pairs that cartridge with a 27 1-inch cold hammer-forged barrel producing muzzle velocities around 2,970 feet per second. What I find most compelling when I study this platform as a collector is the 3-lug bolt design with its 60-degree lift. Traditional 90-degree throw systems work fine at room temperature, but in severe cold, when gloves are mandatory and fine motor control is compromised, that extra 30 degrees of throw becomes a meaningful, tactical disadvantage. Seiko understood that reliability under thermal contraction meant engineering tolerances that most European manufacturers weren't designing to. The TRG-42's receiver and bedding system were specifically constructed to maintain precision across a temperature range that would render less disciplined designs unreliable. Finnish forces adopted it, Nordic allies adopted it, multiple NATO members adopted it, and in doing so, they collectively codified what was once considered a niche specialty precision engineering for extreme environments into a times baseline requirement, times for any serious military sniper system. That's a doctrine shift, achieved through the barrel of a rifle from a small city in southern Finland. 6 SVD Dragunov, 1963. Moscow. The Soviet Army issues a requirement that, when you understand its full implications, is genuinely radical for its time. They didn't want a traditional sniper. They wanted a designated marksman, a rifleman, times within a standard infantry squad, times capable of engaging targets at 600 meters, providing organic long-range capability at the lowest tactical level. It's a fundamentally different philosophy from Western sniper doctrine, which treated precision long-range shooting as a specialized, separately deployed capability. Yevgeny Dragunov's winning design emerged from a competitive Soviet development process. The SVD Snaperskaya Vintovka Dragunova is chambered in the 7.6 2x54mm rimmed cartridge, a round that dates back to 1891 and the Mosin Nagant rifle. That the Soviets chose to retain this cartridge rather than develop something new was itself a logistical argument. An army of the Soviet Union's scale runs on standardized ammunition chains, and disrupting that chain has cascading consequences. The SVD's short-stroke gas piston action, 24, 4-inch barrel, and 10 round magazine produced a platform weighing just 9.5 pounds unloaded. With the standard PSO-1 optic, a scope that included a range-finding reticle specifically calibrated for the average human silhouette, its documented effective range reached 800 meters. Over 1.2 million units produced. Vietnam, Afghanistan, Angola, Iraq. Every Soviet-aligned conflict of the Cold War era carries SVD DNA. As a collector, the PSO-1 optic alone is a historical artifact worth studying. But the real legacy of the SVD is the idea it proved at scale. Squad-level long-range capability could be standardized, sustained, and replicated across an entire military. Every major army that faced Soviet forces studied this. Some copied the rifle. All eventually adopted the doctrine. 5 Barrett M82. This is the one that shouldn't exist, and that's precisely why it matters. 1982. Ronnie Barrett is not a gunsmith by trade. He's a photographer in Tennessee who wants a .50 caliber semi-automatic rifle and cannot afford to buy one, so he decides to build one. Working without formal engineering credentials, operating out of what was essentially a home workshop, he develops a functioning prototype chambered in 50 BMG, a cartridge designed for the M2, Browning heavy machine gun, not a man-portable rifle. The short-stroke gas-operated action he engineered, paired with a muzzle brake that redirects propellant gases laterally to reduce felt recoil, made a semi-automatic mechanism viable at pressure levels that would otherwise be punishing to the point of uselessness. 29-inch barrel, 57 inches overall. 29.7 pounds, every ounce of it justified by what the recoil management system requires to function. 10-round magazine. Effective range against material targets, 1,800 meters. Here's the detail the official histories tend to smooth over. The U.S. military initially declined the M82. It entered American service only after Dutch and Swedish forces purchased it, and American personnel in the field, watching their NATO allies use it, began specifically requesting it. The adoption came through the back door. The M82A1 variant reached the U.S. Army in 1990, arriving just in time for Operation Desert Storm. And in that theater, American forces discovered something that wasn't in Barrett's original design brief at all. The M82A1 was extraordinarily effective at disabling Iraqi aircraft, radar systems, and light vehicles at distances that made the shooter effectively invisible to the target. Anti-material times use at extreme range, not in the spec sheet, discovered in the field, and permanently recategorized the platform. Every collector who handles an M82 is holding the consequence of one man's financial frustration and mechanical stubbornness. That's not a common origin story. For McMillan TAC-50. The 22nd of June, 2002. Shah-i-Kot Valley, Afghanistan. Canadian Master Corporal Rob Furlong confirms a kill at 2,430 meters. Take a moment with that number, 2,430 meters. The effective range of most modern assault rifles is around 500 meters. Furlong's shot traveled nearly 5 times that distance through elevation, wind, and the atmospheric variables that make long-range ballistics less a science than a negotiation with physics. The rifle was the McMillan TAC-50. Arizona-based McMillan Firearms built this platform as a manually operated bolt-action anti-material rifle chambered in 50 BMG. 29-inch cold hammer-forged fluted barrel. 57 inches overall, 26.5 pounds unloaded. The choice of bolt action over semi-automatic at 50 caliber is a deliberate accuracy argument. Semi-automatic mechanisms introduce timing inconsistencies at extreme pressure that accumulate into dispersion at very long range. Bolt action eliminates that variable entirely. The rifle's only mechanical job, beyond igniting the cartridge, is to times not introduce its own error. The philosophy embedded in the TAC-50 is one that every serious precision rifle collector eventually arrives at. The best long-range rifle is the one that lies least. Atmospheric conditions will confound you. Ballistic computation has limits. The rifle itself should not be among the variables you're managing. In 2017, another Canadian soldier in Iraq extended that record to 3,540 meters using a TAC-50. Both records verified by witnesses, after-action documentation, and independent ballistic analysis. 3. CheyTac M200 Intervention. If you want to understand why the M200 Intervention exists, you need to understand the transonic barrier and why it represents one of the most dangerous moments in a bullet's flight. As a projectile decelerates from supersonic to subsonic velocity, it passes through a zone of aerodynamic instability. Shock waves change character. Gyroscopic stability is stressed. At this transition point, bullets that were flying true can be deflected unpredictably. For the 338 Lapua Magnum, the dominant extreme-range cartridge going into the late 1990s, that barrier arrives around 1,400 meters. The question a small Idaho-based company called CheyTac Associates asked around 2000 was, can we design a cartridge from scratch using computational fluid dynamics modeling that maintains stability through the transonic zone at ranges exceeding 2,000 meters? The answer was the 408 CheyTac, a proprietary cartridge developed in partnership with ballistics researchers, not adapted from existing military or commercial stock. A 419, grain bullet pushed at roughly 2,850 feet per second, engineered at the molecular geometry of its projectile shape to preserve flight stability where the 338 Lapua fails. As a collector, the M200 occupies a genuinely unusual category, a rifle and cartridge conceived as a single integrated system rather than a rifle chambered in an existing round. That's rarer than it sounds. 2. Accuracy International AXMC. By 2012, British and NATO special forces were carrying a logistical contradiction in the field. Training environments and urban operations called for 308 Winchester widely available. Relatively low recoil. Excellent for shorter range precision work. Long-range combat operations demanded. 338 Lapua Magnum, with the reach and terminal performance to engage at distances where 308 becomes marginal. 2 mission profiles, 2 calibers, 2 separate rifles, 2 separate training chains, 2 separate maintenance supply lines. The question Accuracy International answered with the AXMC was, what if you only needed one? Refined from the legendary AW and AWM series platforms that established AI as the standard setter for military precision rifles throughout the 1990s and 2000s, the AXMC multi-caliber chassis supports 338 Lapua Magnum, 300 Norma Magnum, and 308 Winchester. The conversion between calibers requires a barrel and bolt head exchange that a trained operator can complete in approximately 10 minutes in the field without requiring a re-zero. In 338 configuration, 2 6-inch barrel, 14.8 pounds, 1-0. Round magazine, in 308 or 5, round, in 338. The AXMC's argument that modularity and precision are not in opposition was not self-evident when it was introduced. The conventional wisdom held that purpose-built specialized platforms would always outperform adaptive systems in their specific role. AI's engineers proved this was an engineering failure of imagination, not an iron law. 1 Barrett MRAD. USS OSIAM is confronting a doctrinal reality that the AXMC had identified but not fully resolved. No single platform was satisfying the full operational spectrum faced by American Special Operations snipers. Urban direct action, close-range precision, mid-range designated marksman work, long-range interdiction, extreme-range anti-material. Each mission profile has its own optimal cartridge. Each cartridge has its own ballistic behavior, training requirement, and logistical chain. The Barrett MRAD multi-role adaptive design is the modular bolt-action answer to this problem. It supports 7.6 2x 51mm NATO, 300 Norma Magnum, and 338 Lapua Magnum, quick change barrel and bolt system, caliber conversion in under 60 seconds in the field. No re-zero required after the swap. In 338 configuration, 26 8-inch barrel, 14.1 pounds, folded length of 46.5 inches. Exceptionally compact for the capability it delivers. In 2019, after a rigorous competitive procurement process, USS OSIAM selected the MRAD as the Mark 22 Advanced Sniper Rifle. The requirement, critically, was not for the most accurate rifle in any single caliber. It was for the most capable platform times across all mission profiles. The MRAD won not by being the best at one thing, but by refusing to be second-rate at anything. I've held a Mark 22, and what strikes you, handling it as a collector who has spent time with everything from a 1940s Springfield M1903, a 4, to a modern CheyTac, is how completely it synthesizes 60 years of military sniper doctrine into a single chassis. The GM6's argument for compactness, the SCAR 20S's argument for purpose-built precision, the TRG 42's argument for environmental reliability, the SVD's argument for doctrinal flexibility, the Barrett M82's accidental anti-material revolution. 9 platforms. 9 moments where the existing answer proved insufficient, and someone, a Hungarian engineer, a Finnish metallurgist, a Soviet designer, a Tennessee photographer, decided to replace it with something better. The most interesting question isn't which one times rank times highest. It's which single platform forced the most fundamental rethink of what a sniper rifle was supposed to be. That answer will tell you more about military doctrine, ballistic science, and the intersection of engineering and operational necessity than any ranking ever could. Drop your answer in the comments. I read all of them.